Hi everyone, welcome back to my channel. In this video, I am going to solve 2014 to 2016 previous year CSIR NET previous year questions from Polymer Chemistry. And in this part 1, part 2 and part 3 video link I have mentioned in description. Please go through that. Now let's see the question. Question number 1. Mark Houwink equation eta is equal to k into m to the power a is used for the determination of. Here 4 options given. Number average molar mass, weight average molar mass, viscosity average molar mass and Z average molar mass. This question is asked in CSIR in December 2016. Now we'll see the solution of this question. Here the Mark-Houwink equation is eta is equal to k into m to the power a. Here eta is equal to intrinsic velocity, k and a is equal to Mark-Houwink constants, m is equal to viscosity average molar mass, that is equal to mv. Now therefore the Mark-Houwink equation is used to determine the viscosity average molar mass of a polymer. So for the first question, correct answer is C, viscosity average molar mass. We'll see the second question. The condensation of a hydroxy acid produces a polyester with the probability of linkage at both ends being P. The mole fraction of a K-mer chain formed is. Here 4 options given. P to the power K, P into 1 minus P to the power K minus 1, and option C is P to the power K minus 1 into 1 minus P, and option D P to the power K minus 1. This question is asked in CSIR NET June 2016. Here we'll see the solution. For a polyester formed by condensation polymerization of a hydroxy acid, according to the Flory distribution law, the mole fraction of a K-mer is xk is equal to 1 minus P into P to the power K minus 1. Here, rho is equal to probability that a functional group has reacted, that is extent of reaction, and 1 minus rho is equal to probability of chain termination, that is unreacted end group. So therefore the mole fraction of a K-mer chain is xk is equal to 1 minus P into P to the power K minus 1, or equivalently xk is equal to P to the power K minus 1 into 1 minus P. Here therefore for second question, correct answer is option C, that is P to the power K minus 1 into 1 minus P. Now we'll move to the third question. This question has asked in CSIR NET December 2016. The distribution of molar masses in a typical polymer sample is shown below. Here graph is given as weight fraction versus molecular weight. Here the A, B and C represent option A MW bar, MV bar and MN bar respectively, and option B is MN bar, MV bar and MW bar respectively, and option C is MV bar, MW bar and MN bar respectively, and option D is MN bar, MW bar and MV bar respectively. Now we'll see the solution. For a polymer molar masses, the general relation is Mn bar greater than Mv bar greater than Mw bar greater than Mz bar. In the graph, molecular weight increases from left to right. Therefore, A leftmost is equal to Mn bar and B middle is equal to Mv bar and C rightmost is equal to Mw bar. Hence, the correct answer is option B, Mn bar, Mv bar and Mw bar respectively. So, we'll move to the fourth question. This question is asked in CSIR NET December 2015. The correct expression for the product Mn bar into Mw bar, where Mn bar and Mw bar are the number average and weight average molar masses of a polymer. Here options given. Option A, N by N into summation I, Ni, Mi, and option B, 1 by N into summation of NiMi square, and option C, N divided by summation of NiMi. Option D is summation of NiMi square divided by summation of Ni. Here we'll see the solution. For polymers, Mn is equal to summation of NiMi divided by summation of Ni, and Mw is equal to summation of NiMi square divided by summation of NiMi. Multiply both. So Mn Mw is equal to summation of NiMi divided by summation of Ni into summation of NiMi square divided by summation of NiMi. The term summation of NiMi cancels out. So we will get Mn Mw is equal to summation of NiMi square divided by summation of Ni. Now, so you will get the Mn bar into Mw bar is equal to summation of NiMi square divided by summation of Ni. So correct answer option D, summation of NiMi square into divided by summation of Ni is the correct answer. We will see the fifth question. This as asked in CSIR NET June 2015. The intrinsic viscosity depends on the molar mass as eta is equal to k to the power ma. The empirical constants k and a are dependent on option A solvent only, option B polymer only, option C polymer solvent pair, option D polymer interaction. Here the correct answer is option C polymer solvent pair. Now we'll see the explanation. The Mark-Houwink equation is eta is equal to k into m to the power a. The constant k and a depend on the polymer, the solvent and the temperature. Therefore, k and a are characteristic of a polymer solvent pair at a given temperature. Hence, option C is the correct one. Now, we'll see the sixth question. This has asked in CSIR NET June 2015. A sample experiment revealed that PVC formed in the medium has Mn is equal to 13 and Mw is equal to 16, where Mn stands for number average molar masses and Mw for the weight average molar mass. The variance of Mn will then be option A 39, option B 3, option C 1 and option D 0.87. We'll see the solution. For polymers, Mn is equal to summation of NiMi divided by summation of Ni, and Mw is equal to summation of NiMi square divided by summation of NiMi. Here given Mn is equal to 13 and Mw is equal to 16. The variance is given by sigma square is equal to Mn into Mw minus Mn. Now substituting the values. Sigma square is equal to 13 into 16 minus 13. So sigma square is equal to 13 into 3. So sigma square you will get as a 39. So correct answer is 39. Option A is the correct one. Now we'll move to the seventh question. For a polydispersed macromolecular colloid, osmometry gives option A weight average molecular weight, option B number average molecular weight, option C both weight average and number average molecular weight, and option D viscosity average molecular weight. Now we'll see the solution. See, osmotic pressure is a colligative property which depends on the number of molecules present in the solution rather than their individual sizes or masses. For polymer solutions, osmometry therefore measures the number average molecular weight, it is Mn. So, pi is equal to CRT divided by Mn, where pi is equal to osmotic pressure, C is equal to concentration, R is equal to gas constant, and T is temperature, and Mn is equal to number average molecular weight. Hence, osmometry gives Mn. So, the correct answer is option B, number average molecular weight. I hope you understood. Next, we'll move to the 8th question. This has asked in CSIR NET June 2014. In radical chain polymerization, the quantity given by the rate of monomer depletion divided by the rate of propagating radical formation is called option A kinetic chain length, propagation efficiency, propagation rate constant, and depolymerization time. We'll see the solution. In radical chain polymerization, the quantity is equal to rate of monomer depletion divided by rate of propagating radical formation. That is called kinetic chain length. So, here the correct option is option A. Kinetic chain length is the correct one. I hope you understood this video. In next video, I will come with some more previous year questions from CSIR NET. If you like this video, please like, share and subscribe to my channel. Thank you. Have a good day.